Hello and welcome back to this series on Python for the Digital Humanities. In the past video, I spoke about the benefits of data structures that are in text files and how we can actually store our data in text files and why you might want to consider that. We're going to do something similar in this video, and we're going to talk about Excel. And then the next video, we're going to talk about storing data in XML files. And then finally, we're going to deal with storing data and processing data with pandas. The reason why I mention that right now is because a pandas is a Pythonic way of kind of doing something kind of similar to Excel in memory. I'll get to that in lecture number 25 down here. So, why would we want to use Excel? We're probably all familiar with Excel, at least in some way. You are familiar with the fact that Excel is a data structure that has rows 1, 2, 3, 4 down this way, and columns that are represented by letters A, B, C, D, all the way down that way until you get to eventually double letters, I think is what happens once you get past Z, but we mostly don't do that. In this video, I want to talk about why you would use Excel as a way to store your data, when you should do it, and also, and this is the most important thing, when you shouldn't use Excel. It was once commented to me that using Excel and working with Excel exclusively gives you something a little like Excel brain. When you use Excel exclusively, you start to see all data structures as in Excel terms. And it is very important if you're going to continue in DH to not do this. So what do we do when we use Excel? We typically have something like name, age, and then we can do DOB, date of birth. So in the name column, you would have a name. So Cindy, age, we're going to say 50, date of birth. We're just going to use years right now. Let's just say 1959. I'm just kind of throwing these out. I know that if you were born in 1959, you're not 50 years old in 2020, but this is just for these purposes. We're going to say Bill, 52, 1961. Now I'm just being silly because I'm going backwards. 1957. There we go. And we can keep on going down this list. We can say Anna, 20, and we're going to say 1943. Again, I know these numbers don't line up. That's not the point. We can do fun things and we can embolden that section. But what we have here is a very, very simple data structure. So when do you want to use Excel as a way to store your data? It's actually kind of inefficient in Python to store data in Excel, but sometimes you really do want to. And the reason why you want to, and when you actually use it, is in two cases. The first case is when you need a very simple, almost like a database to store your information that is easy for people who are not comfortable with coding to look at, a system that they're familiar with. These are the times that you would want to use that so that they can easily input new data, and your Python functions, your Python scripts can simply go through and, like we saw before, figure out how many rows there are and read in that data. And as the Excel spreadsheet is updated, the Python program will account for that automatically. That's a scenario in which you'd want to use it because it's familiar with people who are not familiar with Python. Another time that you want to use it, and this is always when you want to use it, is when you have consistent data. So if I am working with data that only will have these three things that I need to know, a person's name, a person's age, and a person's year of birth. I should probably change that to YOB. I'm not going to worry about it. This is the other time that you want to use Excel. The only time you should ever use it is when your data is entirely consistent and when you don't need to actually have any other information. And the reason why I say that is because Excel is very bad at handling inconsistent data. So in cases where you might have, let's say for Anna, we have age, date of birth, and another thing that's really important about her might be gender for her. So we're going to say female. But we don't actually have this as an important piece of information for Cindy or Bill. This is a time when Excel will fail you. Or what if we are dealing with something like pets? This is a better way to actually demonstrate this. We know, let's say pet names, pets and pet name. So Cindy has one pet, Bill has one pet, and we're going to say that this one's name is Piper, why not? And this one's name is Sally. However, Anna is inconsistent in this database. She actually has two pets. Here's the problem. I only have pet name, singular, and E. How do I account for Anna having two pet names? Well, I can do this very easily if I want to represent the data visually. I can simply say her pet's names are Toshiba and and Oliver. Cool. If I'm working with Excel, I can just drag this over and no problem. But in order to account for this inconsistency in a Python script, I now have to add in a conditional if there is a comma in this pet name section, or if there is more than one here in this pets area to look for a comma. What if the person entering the data didn't use a comma? What if they were inconsistent, and this will happen all the time to you when you're working with data, and they put and? Now, if I'm looking for a comma and I don't see one, yet I see two, I've got something weird here. You might want to say, well, maybe that person, that little pet, just has one name. So what if Toshiba has a name, Toshiba Mac? And that's just one pet name. So you might be thinking to yourself, I can account for it by spacing. You can't do that, because what if the pet actually does have two names? My point here, these are silly examples, but my point is demonstrated. It is difficult to write Python scripts that can account for inconsistent data structures that exist in Excel. The reason why you don't want to use Excel always is because you cannot always account for users to enter the correct information, the correct format in an Excel spreadsheet every single time. If they don't, it's going to break your script, or you're going to receive an error. And then you have to go back through, find out where they made the mistake, and correct it. This is just a very simple mistake, but imagine if you were working with an Excel data structure that had 20 columns of information about a person, and then you have to account for that person typing in everything correctly. This is a very long demonstration, but one that I really want you to think about and consider. If you are dealing with Excel data that is going to be very simple, like this over here, just name, age, and year of birth, go for it. A person is never going to have more than one age. A person is never going to have more than one date of birth. It's when you start working with data that might have more than one value or might have inconsistent values that you want to start turning to other options. And one of the best things that you can turn to is actually something called JSON files. I'm not going to get to JSON files in this series. That's going to be saved for part 2 of our Introduction to Python series when we start doing more advanced things. But for right now, just know that there are other options out there for inconsistent data structures. In the next video, we're going to look at one of these options, and that's something called an XML, or it's basically a markup language that works in tandem or as a replacement to HTML. That's all for this video, though. Start thinking about Excel as a consistent data structure, not simply as this visual representation of data that we're used to. So that's all for this video. Keep on listening. If you've enjoyed it, please like and subscribe down below.